Nara Prefecture's Asuka District, home to Japan's 8th century capital. This is where you'll find the world's oldest wooden buildings. Horyuji Temple. These wooden buildings have stood in grandeur for over 1,300 years. In Japan, rain and humidity pose dangers to wooden buildings. Horyuji Temple contains ingenuity to protect against such threats. One example is the length of the eaves. The roof extends far out, keeping rain away from the building itself. But that alone isn't enough to preserve timber for 1,300 years. Exploring the techniques hidden here is the subject of this show. This photo was taken during Horyuji's renovation, which took half a century to complete. What you see here is the planing process, in which the wood is shaved away to expose a new surface. A kanna, or Japanese plane, is a traditional carpenter's tool. A blade is inserted at an angle into a hollowed rectangular piece of hardwood. The blade protrudes slightly from the rear. Using this blade, the wood surface is shaved. How is this process of planing the surfaces of wood related to the durability of Japan's wooden architecture? We'll explore the amazing skills of craftsmen with unrivaled technique.
Welcome to Capturing Master's Workmanship. Since ancient times, Japan's wooden architecture has literally been shaped by the kanna. Today we'll use the latest technology to reveal the secrets of what this tool can accomplish in the right hands. Let's capture the skills of a master.
Nishio City, Aichi Prefecture, near the center of Japan. A national competition was held here in the summer.
皆さん頑張って削りましょう。
This is the national Kezurokai competition in Nishio. Competitors strive to cut the thinnest wood shavings using kanna. Carpenters and ordinary people with the right skills gather here from across Japan. This annual competition seeks to foster the improvement of kanna skills in Japan. You can see how thin the shavings are for yourself. They're transparent. But if the strip tears or breaks, the participant is disqualified. Measurements are made with great care. The measurements are in microns, which are thousandths of a millimeter. This year, there were around 150 participants. The champion was a young carpenter, just 24 years old. His record was 7 microns, or 7 thousandths of a millimeter. In one corner of the venue, a crowd was gathered.
それはこの両側だけ研ぐっす。わざと。
This man displaying his blade sharpening skills is a 3-time winner of this competition and a legend for his skills with the kanna. His name is Hosoda Yoritaka. He holds the all-time record with a shaving just 3 microns thick, or 3/1000ths of a millimeter. What's the secret behind the technique that made such a feat possible? Hosoda has honed his skills working as a carpenter for 15 years. At his workshop in Nishio City, where the competition is held, he processes construction materials used mainly to build houses. Kanna are used primarily to shape and finish the surfaces of pillars in houses and other structures. Here, he works with his kanna daily. To see just how good Hosoda's legendary wood shaving skills are, we asked him and his apprentice, Yamamoto Kojiro, to demonstrate. Hosoda, the master, makes delicate adjustments to the blade. Then, slowly and carefully, he begins drawing the kanna. How thin was his shaving? Just 5 microns, 5/1000ths of a millimeter. Yamamoto, the apprentice, has been a carpenter for 5 years. It looks like he's made quite a thin shaving. But it's 15 microns, 3 times the thickness of his master's. Hosoda's apprentice is amazed by the difference as well.
すごいと思います。他の人が多分気にしんようなとこまで追求するんで、研究してやっとるんで、多分それが薄くなる秘訣だと思うんですけど、そういうとこがすごいなと思うんですけど。
How on earth can he shave wood so thinly?
Incredible! It's so thin. We need something to analyze this amazing skill. That's too fast for the naked eye to see. And here it is.
The Phantom T1340, a high-speed camera with superb resolution. The latest compact camera used in both space exploration and military applications in the US and elsewhere.
But why stop there? And this one.
The Model 2525 Laser Doppler Velocimeter makes precise measurements of speed without contact.
Let's see what they can do. Time to capture the skills of a master.
Using this cutting-edge technology, we'll examine the master's technique. First, we set up our advanced high-speed camera right next to the wood. And we filmed a close-up of the moment that the master's kanna blade shaves the wood. Time for a closer look. This close-up video shows the action of the blade. The thin blade moves across the wood. You see the blade lightly touching the wood, shaving away a thin surface section. Let's compare it with video of his apprentice. Can you see the difference in the shaving's thickness? Let's compare them again. Above, the master's work. By contrast, the apprentice. The difference between shavings is clearly visible using the high-speed camera. Their method is the same, so why is there such a difference?
みんなカンナって下にこう押さえつけてドーンって削ってくるんですよ。その力はいらなく引っ張る力で削ってくる。下に力を入れる。
The kanna's blade isn't pressed against the wood. It turns out that this is the secret of the master's technique. We also noticed subtle differences in the motion of the kanna. We decided to measure changes in speed at the beginning and end of each 30-centimeter pull. We'll use a laser Doppler velocimeter, which makes precise measurements of speed using infrared light. This led to amazing results. Time for a closer look. This graph shows changes in speed at 2 measurement points. It shows that the kanna was moving at an almost constant speed at both locations. We also measured the speed of his apprentice with 5 years' experience. Here's the result. It's clear that the speed is quite uneven. Side by side, the difference between measurements was obvious. Even the measuring equipment technician was astonished by the result.
おそらく人間がまっすぐ一定速で動かすってこれはすごい難しい話だと。やっぱり熟練のそういう経験でなってくるんだと思いますね、うまく。
This result amazed the master as well.
意識したことなかったんですけど、俺もめちゃめちゃ勉強になったです。あ、本当ですか？全然こんなの本当初めて。
The second secret of the master's technique is to maintain a constant speed while drawing the kanna. We wondered if there was any difference in wood that has been shaved this way. We decided to examine the 2 wood surfaces under a digital microscope. And we found yet another surprise. This is a magnified image of the wood surface shaved by the master. The circles in the image are wood cells. And here's the surface that was shaved by the apprentice. Can you see the difference? In the first image, the wood cells remain intact, but the cells in the apprentice's sample are crushed and shapeless. Building materials shaved by both master and apprentice. We tried dripping water onto the 2 surfaces. First, the apprentice's, with its broken cells. The water spread quickly. And here's the wood shaved by the master, with cells still intact. You can see the difference. The water immediately spread and soaked into the apprentice's wood. But on the master's wood, spherical droplets remain on the surface. In short, the master's wood will be more resistant to rain. One reason Japan's timber buildings can resist high temperatures and humidity is the amazing techniques of kanna masters. A smooth wooden surface, possible only for a master of this thin shaving technique. How did he learn this amazing skill?
練習あるのみ。練習ひたすらして、何かにぶつかった時に親方に聞いてっていう繰り返しでここまで来れたのかな。
Hosoda gained his skill through exhaustive practice. The final wisdom Hosoda imparted to us was,
技術がめちゃめちゃある人で、例えばホームセンターに売ってるカンナで3ミクロンが出るかって言ったら出ないんで、技術が8割で道具が2割だと思います。硬い、柔らかい、研ぎやすい、研ぎにくい。同じ人が作っとるやつでも刃が違う。
Looks like what's amazing isn't just their skill in using this tool, but the craftsmanship that went into making it. Let's find out what extraordinary techniques are hidden in how this tool is made.
Miki City, Hyogo Prefecture, near Osaka in western Japan. There's a kanna maker here who is highly regarded by the master carpenter Hosoda. This town has long been famous for its blacksmiths. There is even a museum with a collection of blades made in the area. From chisels to saws, the collection spans 400 years. In one corner, kannas are on display. Among them, one brand in particular has won fame for Miki's craftsmen. The name is Chiyozuru. Their blades are masterpieces, prized by carpenters across Japan. Chiyozuru brand kannas are made in an old workshop on the city's outskirts. This is Morita Naoki. The blades shaped by the hands of this 43-year-old craftsman are in high demand. The current Chiyozuru brand name, Sadahide, has lasted over 70 years. The founder was Chiyozuru Sadahide, active in the mid-20th century. His apprentice, Morita's own master, inherited his techniques and name. And 2 years ago, Morita in turn took over the entire business as Chiyozuru Sadahide III. Chiyozuru brand kanna blades are both extremely sharp and long-lasting. To make the blade, iron and steel are bonded, then repeatedly hammered and stretched. The final step after shaping and polishing is tempering, which in Japanese is called yakiire. The blade is heated to 800 degrees Celsius, then quickly cooled in cold water. This process is crucial to the strength of the blade.
一番重要なのは焼き入れですね。温度の管理で高度は変わります。だいたい780から820ぐらい。材料によったら800度まで。同じ熱し方をしないと同じ硬さは出ないので、ここを外してしまうともう鋼として切れ味はもうできない。そこが一番重要なところですね。
Chiyozuru uses only his naked eye to judge the right moment for tempering when the blade is within 20 degrees of 800 degrees Celsius. During the process, natural light is shut out and all lights turned off. This is because subtle changes in color will tell him when the optimum temperature is reached. He inserts the blade into red-hot coals. he gazes into the furnace. Then, with precise timing, he removes the blade. But how does he decide on this moment?
だいたい経験的にこの温度の色だったらもう焼き入れされないやろうなっていうのがすぐ分かるんです。もう経験的に。でも高い温度もこれ以上すると材料が傷んでるっていうのは見えてくるんで、慣れてくると目で見ればすぐ分かります。
The correct timing for tempering the newly forged kanna is very precise. But how on earth does he judge the tool's temperature? Let's find out. Using this.
The Thermora NIR2, a two-color thermal imaging measurement system that analyzes temperatures in real time.
Let's see what it can do. Time to capture the skills of a master.
First, how close did the blade the master tempered come to his target of 800 degrees Celsius? We measured the blade's temperature as the master pulled it from the furnace just before plunging it into water. This is the image filmed by the special camera. What's important is the temperature of the cutting edge at the bottom of the screen. The result is 780 degrees Celsius. 3 times we measured temperatures right after he took a blade from the furnace. Sure enough, all of them were within 20 degrees, plus or minus, of 800 degrees Celsius. So, how does the master determine the timing for tempering? This time, we used a camera mode that can detect differences in temperature by color and filmed the furnace's interior. Time for a closer look. Just before the master removed the blade for tempering, there was a change in the furnace. Green flames appeared suddenly, indicating temperatures over 900 degrees Celsius. And 4 seconds after the green flame appeared, the master pulled out the blade. Let's play it again. Hot sparks from the fire. This is how the master judges the correct timing to quench the blade. What does it actually look like through Chiyozuru's eyes? This is the image seen by an ordinary camera. Then, there was a moment when sparks flew up. Apparently, he hadn't missed this flare-up and knew it was time to temper. Chiyozuru Sadahide's amazing skill is determining the fire's condition using only his eyes. Through perfect timing, Chiyozuru Sadahide's blade has reached an ideal temper. Can we see evidence of the difference in hardness? We checked both the finished blade and a blade that failed to temper under a digital microscope. This image, magnified 700 times, shows the surface of the successfully tempered blade. And this one, tempered at too low a temperature, is the failure. Comparing them side by side, the surface of the properly tempered blade on the right appears smooth and clean. This means that the metal's components are lined up neatly, creating a hard and durable blade. Determining the blade's temperature by watching the flame is how hard kanna blades are made. So how did the master learn his techniques?
私の時がその師匠の背中を見てそこから学べっていうことで、育てられてきたんですけど、一緒にやってたのは15、16年ぐらいですかね、弟子入りしてからずっと。我々の時代の世代からするともう完全になかなかいないだろうっていうぐらい職人体質な感じでしたね。一言で言えば大胆にして繊細っていう感じですかね。
Chiozuru III learned this incredible technique by watching his own master again and again, accumulating experience over time. Chiozuru kannas are made with machine-like precision and the utmost care. Kannas engraved with the workshop's name are considered without equal and prized by skilled carpenters.
So, what do you think? Using the latest technology, we've taken a closer look at the world of the kanna, the Japanese plane. Not only that, we also captured the mindset of the craftsmen, their workmanship and dedication to pursuing the highest levels of their art.
Japan takes pride in its world-class wooden construction. It's supported by the skills required to prepare wooden surfaces with a kanna, creating building materials that can withstand the country's high temperatures and humidity. And all of this was made possible through the traditional skills of the craftsmen who created the kanna itself.
What secrets will we uncover next? If you see any amazing workmanship you'd like us to investigate, let us know. Until then.
This program was made possible by the Japan Foundation.